Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how you can predict the products of an electrolysis reaction. Basically what I'm going to show you is how you can figure out which half reactions are going to be happening at your anode and your cathode. So let's get into this. So the first problem here, basically where we're asked is for these two, predict the half reactions occurring at the anode and the cathode for the reaction of each reaction. Alright, so for the electrolysis of each reaction, excuse me. So the first one is we have a mixture of molten aluminum bromide and magnesium bromide. So we have to figure out what's going to happen at the anode and the cathode. Well, at the anode we know oxidation occurs. So the anion is going to be oxidized at the anode, and the cation is going to be reduced at the cathode. So we only have one anion, bromide. So that's going to be at one of the excuse me. That's going to be on one of the electrodes. It's an anion. So that's going to be gaining an electron. That's going to be losing an electron and forming bromide. So that's going to be oxidized. So that's going to be oxidized. If we write that down, we're going to have our Br minus aqueous. That's going to lose an electron, and we're going to get Br2 liquid. And forgot to write down the electron. Oops, sorry. So we're going to have a 2 here, and we have 2 electrons there. Okay, so all right, sorry about that. So I have to change this. This is not aqueous. This is liquid because we're dealing with melted. So it's not dissolved in water. So this is liquid, and this is gas. Okay, so this is oxidation. This is happening at the anode. So that's one half reaction. So one of the other things to keep in mind is because this is molten, there's no water. So if it was aqueous, it'd be water, and then we would have to figure out whether or not water is going to be oxidized or reduced during electrolysis, because water is also available for that reaction as well. But since we're molten aluminum bromide and magnesium bromide, then we don't have to worry about the possibility of water being oxidized or reduced at the electrodes. So that's why it's important to keep that in mind. So pay attention whether it's aqueous or if it's molten and there's no water involved. So this is going to be at the anode. What about our other half reaction? Well, we have 2 cations. So either one of those can be reduced at the cathode. So let's write them both down. So we have aluminum. So aluminum 3 plus 3 electrons is going to give you aluminum solid. And then we have magnesium Mg2 plus 2 electrons is going to give you magnesium solid. So there's our reduction. So reduction. So which one of these is going to happen at the cathode? That's what we got to find out. So what we need to do is we need to look at the electrode potentials, the reduction potentials for each of these. So if we look on our table, okay, so on the table here, we're going to get a standard electrode potential of negative 166 for aluminum. And again, I need to make sure we get this as liquid. So these are liquid. So the So the standard electrode potential for that one is negative 1.66 volts. And the for magnesium is going to be, let's see, that's going to be negative 237 volts. So this one's going to have an electrode potential of negative 2.37 volts. And so looking here, you can see that the reduction half reaction potential, the electrode potential, the standard electrode potential is more negative for magnesium than it is for aluminum. So if you remember, the more positive the electrode potential, the more easily it can be reduced. So this one is more negative, this one's more positive. This is actually negative here. So this is more negative, this is less negative, or this is more negative, this is more positive. Either way, the more positive or the less negative, the more easy it can be reduced. So this is going to be the reduction reaction at the cathode. So we can predict what the products are going to be during the electrolysis. So the products are going to be bromine gas, Br2 gas, and aluminum solid. So what about the next one? So here, but what if we have aqueous solution of lithium iodide? So let's go ahead and do that one. Okay, so now we're going to look at aqueous solution of lithium iodide. So now that we know that's aqueous, it's dissolved in water. So if we do the electrolysis of this solution, water could be either reduced or oxidized. So we need to compare our ions to that of water to see what's going to happen. So again, at the anode, your anion is going to be oxidized, and your cation is going to be reduced. So let's look at the anion. So here, give me a minute. So here, the reaction, or at least one of the half reactions, if we're going to look at oxidation, is going to be lithium, or iodine, sorry. So we have iodine minus, so we're going to have two of them. We're going to lose the electrons. We're going to get I2. So this is going to be aqueous. This is going to go to I2 solid plus 2 electrons. So that's one possibility. The other possibility is that water will also be oxidized. So if water is oxidized, that's going to be, if we look on our table here for the oxidation of water, we'll get 2 H2O, so 2 H2O liquid, and that's going to break down into O2 gas, 4H plus. So we got O2 gas plus 4H plus 4 electrons. 4 electrons. Let me double check I got that right. Okay, so actually this is a liquid. This is going to be liquid. This will be a liquid. Okay, so this is going to be oxidation at the anode. Okay. Now we can look at what the two possibilities for reduction at the cathode. So again, we have our cation. So lithium So lithium plus 1 electron will go to lithium, I want to say liquid. It's going to be solid actually. So solid. And then we also have water. Water can also be reduced. So if we have the reduction of water, it's going to be 2H2O. So here we have 2H2O liquid plus 2 electrons is going to go to H2 gas. So wait, is it 2? No, it's just H2 gas plus 2OH minus. So 2OH minus, 2 hydroxide ions, aqueous. And is that it? That's all. Okay, so these two reduction at the cathode. So all we need to do now is figure out which of these is going to happen. So we need to compare the electrode potentials, the standard electrode potentials. So we looked that up in our tables. So for iodide, it's 0.54. So here, the standard electrode potential is 0. Double check that again, 0.54 volts. For water, it's going to be 0.82 volts. 0.82 volts. And the H plus concentration is 10 to the negative 7. Concentration of H plus concentration is 10 to the negative 7 because it's water. Water is neutral pH. And then for the reduction, it's going to be negative 3.04 for the lithium. 3.04, so E is negative 3.04 volts. And for the reduction of water, it's going to be negative 0.41. So negative 0.41 volts. And so again, we're looking at the respective standard electrode volts. And so, looking at the standard electrode potentials for oxidation and reduction, we can choose which one of these is going to more easily happen at each of the electrodes. So, at the anode, we're looking at the more negative electrode potential. So, the more negative electrode potential is going to happen more easily. So which one of these is more negative, or the other way to put it is less positive? This one is more positive, this one is less positive. So this one is more easily going to happen at the anode. So this one is going to more easily give up its electrons than water is. Okay, what about the cathode? So the cathode is the opposite. So it's the more negative one is the less likely to happen. The less negative one is the more likely to undergo reduction. So you're looking at the less negative one. And so obviously here, the less negative one is water. Even if you were to account for overvoltage, that would add a little bit more to the potential here, the cathode potential here for water, but notice that this is really negative, so it wouldn't even matter. So water would be the other half reaction that would occur at the cathode. And so you can predict your products. And so the products here would be iodine liquid, and you would get H2 gas and OH minus. If you like my videos, like, share, subscribe, hit the notification bell, put a comment in the comment section. Thanks. See you next time.